Late fusion multimodal models. Gemini may be a late fusion model. Late fusion involves combining the outputs of independent, modality-specific models at a later stage in the processing pipeline. Late fusion allows each modality to be analyzed and processed individually. Advantages: modality-specific expertise. Late fusion capitalizes on the strengths of individual modality-specific models, each trained on a specific type of data and optimized for its unique characteristics. This allows for specialized feature extraction and representation learning within each modality. This may lead to better performance in modality-specific tasks. Flexibility and adaptability. The modular nature of late fusion allows for easier integration of new modalities or model updates. Adding a new modality simply requires training a dedicated model for that modality and integrating its output into the existing fusion process. This flexibility is particularly valuable for dynamic environments where data modalities may evolve over time. Interpretability and explainability. By analyzing the outputs of individual models before fusion, it becomes easier to understand how each modality contributes to the overall decision. This facilitates troubleshooting, debugging, and identifying potential biases within specific modalities. Reduced computational complexity. Late fusion avoids early integration, potentially reducing computational cost and memory requirements. This can be particularly advantageous when dealing with large data sets or resource-constrained environments. Challenges: difficulty in capturing intermodal relationships. The late fusion approach might struggle to capture complex relationships between different modalities. This can result in suboptimal performance compared to early fusion techniques that explicitly model these relationships. Potential for error propagation. Errors or biases in individual modality-specific models can propagate through the late fusion process and negatively impact the overall outcome. Need for careful calibration and synchronization. To ensure optimal performance, the outputs of individual models need to be carefully calibrated and synchronized before combined. This requires additional processing and effort in the late fusion pipeline.